All right, so this is going to be a video on graphing trig functions in calc/pre-calc. I'm going to focus on, again, sort of the way I've come to understand, the way I was kind of taught it and learned about it. So again, this could be different than how your teacher teaches it, but it should net you the same result. So hopefully, if you're having trouble, this might help you in some way. So we'll start with the basic one, like, just how do you graph sine? Because everything's going to be revolving around different changes to the base graph. So we should know that sine of x, the graph comes from the unit circle, right? And so sine is the y number. So when you take sine of 0, you get 0. When you take the sine of pi over 2, you get 1. When you take the sine of pi, you get 0 again. When you take the sine of 3 pi over 2, you get negative 1. And then when you take the sine of 2 pi, which is all the way around the circle there, you get the same as 0, which is 0. And then you loop back around over and over and over. And so we usually focus on those 5 points: the 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that means that if I plug in a 0, we just said that it's going to give me a 0. Pi over 2 will get me a 1. Pi will get me back to 0. 3 pi over 2 will get me negative 1. And 2 pi will again get me back to 0. So the graph ends up looking something like this. You have, let me narrow down my lines here a little bit. You have 0 as your base point. And then you have pi over 2. Then you have pi. Then you have 3 pi over 2. And then you have 2 pi. And the graph looks like a wave. So you go up to positive 1, back down to 0, back down to negative 1, or not back down, but down to negative 1, and then back up to 0. And so you get this sine-looking wave like this. And that's how all your sine graphs are going to look, is different variations of this wave. So some might be, a little bit skinnier, some might be a little bit wider, some might be shifted down or up, so they don't start in the middle, they start way down here or way down here. So all the variations we're about to kind of go through are just different variations on this little wave function. And we only focus on these 5 points here: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, most people can kind of understand the basic shapes. Like if I do a plus 2 here, well, that just means everything's going to be moved up twice. So this entire graph is going to be, instead of starting at 0, it's going to start at 2. And instead of hitting a max of 1, it's going to hit a max of 3, because 1 plus 2 is 3. So all that's going to happen is that this graph is going to be shifted up 2 spots. Similarly, if I subtracted 2, it's going to shift down 2 spots. So again, most people are aware of that sort of shift there. That's kind of the easy one. What usually gets people is when you start doing stuff inside there, right? So when you do stuff inside of the sine cosine function, what happens is the graph has a period change, so that it still has the same sine wave, but it's no longer going to hit these 5 main points anymore, because we're multiplying to x, or to theta as it's usually written in the problem or whatever. So here's how I tackle this here, right? I know what these 4 points are. These points are going to be 0, 1, 0, negative 1, and 0. I know that if I plug in 0 to normal sine of x, it will get me 0. Or put another way, if I take the sine of 0, I will get a 0. If I take the sine of pi over 2, I will get a 1. If I take the sine of pi, I will get back to 0, so on and so forth. So my goal is to think about, okay, now that I'm doing something to the theta rather than just having it by itself, now that I'm doing something to the theta, what do I need to change about my input to get back to these values here? So for example, for 0, I don't need to do anything. If x is a 0, this is going to be sine of 3 times 0. I hate when I do that. Sine of 3 times 0, which is just sine of 0, which we know is just 0. So this part doesn't change in this case, because 3 times 0 is still 0. I know that sine of 0 is still 0. Everything's all good there, or all Gucci, as the youngins might say, right? Now, here's the problem, though. If I plug in a pi over 2, sine of 3 times pi over 2. Well, and ignore this fact down here. We'll get to that in a second here. Well, that's no longer the same as sine of pi over 2 anymore, right? This is not pi over 2. This is 3 times pi over 2. So if I plug in a pi over 2 right now, as it stands, if I plug in a pi over 2 for x and then multiply it by 3 and then take the sine of it, I'm not going to get a 1. So I have to think to myself, okay, what can I change about this input so that when I do plug it into this, I do get back to being sine of pi over 2, and I do know that it is 1. And what that entails is basically doing the opposite of what's been done to your theta. So in this case, and again, I know I have an x in there, but imagine it's a theta. I'm multiplying the theta by 3, right? Which means that I'm going to take pi over 2 and divide it by 3. So I'm going to take pi over 2 and divide it by 3. And I'm running out of space here. So I'm going to take pi over 2 and divide it by 3, which will give me pi over 6. So I know now that if I plug in a pi over 6 for theta here and say sine of 3 times pi over 6, well, what's 3 times pi over 6? Well, 3 times pi over 6 is, well, just that, pi over 2. And what's sine of pi over 2? Well, I know that that's going to be 1. Again, that's from my 5 main points right here. So I know that in this case, if I have a pi over 6 and I plug that in, I'm going to end up getting a value of 1, just like if I plugged in a pi over 2. And so instead of being 0, and then instead of doing a pi over 2 as my first mark like I did here, my first mark is instead going to be pi over 6. Because at that point, that's the first time where I'm going to hit a 1 value, right? So whatever's happening to the theta directly, I am counterbalancing that by doing the opposite to my 5 main points. I always start with these and then I modify them as need be. So for example, in this case, my next point would be that, if I traveled from pi over 2 to pi, my next thing would go from 1 back down to 0. That'd be the next point I hit 0 is when I plug in a pi here. Well, now since I'm multiplying by 3, I don't need to plug in a pi. I need to plug in a pi that's been divided by 3, or put another way, pi over 3. So if I plug in a pi over 3 for theta here, I should get back to my base number, right? Sine of 3 times pi over 3. Well, 3 times pi over 3 is just going to be the sine of pi, which again we just said is 0. So I know that if I plug in a pi over 3, I'm going to end up getting a 0, and that's where my next point is going to be. It's going to be a pi over 3. And then you can probably tell what's going to happen here. We're going to do the exact same thing to these last 2 points. I'm going to take this, I'm going to divide it by 3. So 3 pi over 2 divided by 3, which will give me pi over 2. Again, that's just some quick algebra there. If I take 3 pi over 2 and I divide it by 3, then I'm going to end up canceling the 3 on top, and I'm just going to be left with pi over 2. So my next marker here would be pi over 2, and again, I know that that's going to end up giving me a negative 1. And then here I'm going to divide this by 3, so that's going to be 2 pi divided by 3, which will be my final marker here, 2 pi over 3, which will get me back to positive 1, and then I have my sine wave, if I can hit my points actually. And then I have my sine wave going through that. It looks like 2 waves, but it's just my messy drawing with my mouse here. So whatever is happening to the theta directly inside the parentheses, you are going to do the opposite to these 5 points. You have to know these 5 points. As part of the unit circle, you just have to know how sine and cosine work with these 5 points, because your entire graphs are going to be based off of manipulating these 5 points depending on what is happening to the theta. And yes, the outside stuff does play an impact. We'll talk about that in a second here. But the main thing people struggle with is when you are multiplying or adding to the theta, what do you do to your base points? And the only thing that you do is you do the opposite of what's being done. So these 5 points you plot on the x-axis on these graphs, they are going to change by the opposite of what's been done to the inside theta there. So if the theta is multiplied by 5, divided by 10, subtracted by 7, you are going to do the opposite to these points over here to counterbalance that fact, right? You want to keep the balance just like in algebra. So whatever happens inside the trig function, you want to do the reverse when you're plotting your 5 points on the x-axis. So, for instance, you can pause right now and see if you might want to try this one out if you want to. So 3, 2, 1. In this case, what's happening to the theta? Well, I'm adding pi over 5. So again, if I plug a 0 in right now, it'd be sine of 0 plus pi over 5, which will be sine of pi over 5, which is something that I don't know. I don't know what sine of pi over 5 is. That's not part of my good old unit circle here, right? There's no pi over 5. There's a pi over 6 and a pi over 4, but there's no pi over 5. So to avoid having to figure this out because I don't know what it is, I'm going to ask myself, okay, what do I need to plug in for x? What do I need to plug in for theta, rather? So that I end up taking the sine of 0. I want this to end up being sine of 0. Because I know what sine of 0 is. I know that sine of 0 is 0. Again, it's part of my unit circle. So how do I make this inside part 0? Well, I do the opposite of what's been done to the theta. Since I'm adding pi over 5, I'm going to end up taking 0 and subtracting it by pi over 5, and 0 minus pi over 5 is just simply going to be negative pi over 5. Because, hopefully we can see here, if I plug a negative pi over 5 in for theta, well, negative pi over 5 plus pi over 5 is going to end up giving me a 0, and I know that sine of 0 is once again 0. So my first point isn't going to be at 0 like it was in the last two graphs, right? Here I start at 0, here I start at 0, but now because of this shift, I am going to end up starting at negative pi over 5. Negative pi over 5. That's going to be, I hate when I do that. That's going to be my first 0 marker, essentially. That's going to be my starting point for my sine wave now. And I do the exact same thing to everything else here. I'm going to move my stuff a little bit just so I have some space to write out what I'm going to need to write out. So I'm going to take pi over 2 and ask myself, okay, what do I need to do to pi over 2 so that when I plug it in, I end up with sine of pi over 2? Because right now, if I plug in pi over 2, it's going to be sine of pi over 2 plus pi over 5. Well, that's going to be pi over 2 plus pi over 5 is going to be, what, 5 pi over 10 plus 2 pi over 10, which is going to give me sine of, I don't know, 7 pi over 10 or something like that. And again, that's something I can't do. I can't do sine of 7 pi over 10. I don't know what that is. So to avoid that, I'm going to ask myself, what do I need to change about my input so that I end up with this? And again, the idea is to do the opposite of what's been done. So I'm going to take pi over 2 minus, not add, but minus pi over 5. Let's think about what that is here for a second. That's going to be 5 pi over 10 minus 2 pi over 10, which would give me 3 pi over 10 if I'm doing my mental math right. 3 pi over 10. So I know that if I plug in a 3 pi over 10, I'm going to end up getting a pi over 2 inside here. Again, feel free to check me if I'm wrong here, but I believe if you plug in 3 pi over 10 plus pi over 5, you do end up getting pi over 2. And then I know that pi over 2, sine of that, is going to end up giving me a positive 1. So once again, instead of my second point being pi over 3, instead of my second point being pi over 2, my second point is going to end up being 3 pi over 10. Right? I think actually my second point here was pi over 6. I started at 0. But so instead of pi over 6, I'm now going to have 3 pi over 10. So I'm going to go somewhere over here. Here's 0, 3 pi over 10. We're just going to eyeball it here. Maybe it's right there. 3 pi over 10. And that's going to be the point where I hit my 1. Right? That's going to be the vertex of that little hump there. And then again, I do the same thing as before. How do I make a pi so that how do I change this input so that when I plug it in, I end up with pi? Well, I'm going to take pi minus pi over 5. Again, doing my quick mental math here, that's going to give me 4 pi over 5, right? 5 pi over 5 minus 1 pi over 5 is 4 pi over 5. And I know that when I plug that in, I'm going to get back to 0. So again, my next point is not going to be pi. It's going to be 4 pi over 5. That gets me a 0. Down here, again, same deal. 3 pi over 2 minus pi over 5. This is going to really stretch my mental math here. That'd be what? 15 pi over 10 minus 2 pi over 10, which is going to end up giving me, let's see here. That'd be 13. What's the minus here? That'd be 13 pi over 10. So that would be my next point over here. 13 pi over 10. That's going to be where I hit my negative 1. And then pi over 2, or sorry, 2 pi rather. 2 pi minus pi over 5. That's 10 pi over 5 minus pi over 5, which is going to give me 9 pi over 5, which will be my last point over here. 9 pi over 5, and I'm going to hit back to 0. And so I'm going to end up getting this sine wave right here, which again is a little bit different than the last two because I've shifted over to the left a little bit, which is what this essentially does. This essentially takes all the points and moves them left pi over 5, which is why I had to subtract. Because remember, left is a negative direction. There's a geometry aspect to this as well. And again, 0, 1, 0, negative 1, 0. So this part right here shouldn't ever change unless you have a multiplier or an addition on the outside. So something like this 1/2 and this 3 is going to change the y values. But for right now, if there's nothing on the outside, this is always going to be 0, 1, 0, negative 1, and 0, right? So the number here and the number that's going to be added or subtracted outside here, these two values, those are going to change your y's. The numbers inside here, the pi over 5 and the 3, those are going to change your x values, okay? So your x values always start this way, your y values always start this way, and then you manipulate them based on what's happening on the outside or what's happening on the inside. X gets changed by what's happening on the inside, y gets changed by what's happening on the outside. Again, I'm taking this more of an algebraic approach rather than a geometric approach. Geometric approach I can usually show you better in person, so I'm going to try to communicate it this way here. So what about this one here, right? So now we have a bunch of stuff going on. So the first thing we're going to notice is my x's have changed because I'm multiplying by 2 times the theta. I should say theta, not x. So what's happening here? Again, I'll give you a chance to do it. 3, 2, 1. Go and pause it if you need. I'm multiplying my theta by 2. So I'm going to take all my x's and do the opposite to reset them essentially. So 0 divided by 2 is going to be 0. Pi over 2 divided by 2 is going to be pi over 4. Pi divided by 2 is going to be, well, pi over 2. 3 pi over 2 divided by 2 will be 3 pi over 4. And 2 pi over 2 is going to just be a normal pi. So those are my x numbers right away. I can even plot them right now if I want to. I'm going to start at 0. Then I'm going to hit pi over 4. Then instead of hitting pi, I'm going to hit pi over 2, because again, this has been divided by 2. Then instead of hitting 3 pi over 2, I'm going to hit 3 pi over 4. 3 pi over, come on, 3 pi over 4. And instead of hitting 2 pi, I'm just going to hit a normal average everyday pi. Right? So those are my 5 key x values to graph this graph here. Now, normally my y's do what? My y's go 0, 1, negative 1. Whoops, 0, 1, 0. 0, 1, 0, negative 1, and then back to 0, right? That's how they've been the last few graphs here, right? That's how they always go. Now, since I have outside numbers, aka a number that's being multiplied to the sign on the outside, not in the parentheses, and being added or subtracted to the sign, now my y numbers are going to change. Now, y's are a little bit nicer. They change exactly as they show. So for example, if I'm multiplying by a half, that means I'm going to take my y's and I'm going to multiply them by a half. I don't do the opposite for the y's. The opposites, like I said, or the y's rather, like I said, are a little bit nicer. If I see a plus 3, that means all my y values are going to get upped by 3. They're going to be added to 3. Now, the order you do them in is just like PEMDAS. You do the multiplication and or division first, so this 1/2 gets taken care of first, and then you add. And yes, the order is important. I can't add it in half. I have to go in order. So, and again, I don't really care if this was written like 3 plus 1/2 sine of 2x, I would do the exact same order. Multiply my y's by a half and then add 3. I don't care which one comes first. You always do PEMDAS, multiplication first, and then the addition. So instead of being 0, it's going to be 0 times a half, which is 0.5, and then added to 3, which is 3.5. So instead of hitting a max at, so I start at, instead of starting at a 0, I'm going to start at a 3.5. So 3.5. So my first point is going to be right there, 0, comma 3.5, right? This is my x and my y. X value of 0, y value of 3.5. So I'm not starting down on the bottom like I did right here, or like I did right here, or like I did right here, because again, I have this shift stuff going on. So instead of starting at a bottom of, oh wait, no, sorry, I did a mistake there, didn't I? It's going to be just a normal 3, not a 3.5. The reason being is because 0 times a half is 0, not a half. So if you were screaming at me because of that, I corrected myself. So this is actually going to be 0. Come on. And 0 plus 3 is going to give me a normal average everyday 3. I apologize for my worse than normal handwriting. I'm not sure why this mouse is kind of acting up on me here. So I'm going to start at 3 now instead of 0. And then I'm just going to down the list and do the exact same thing to my other y values. So this normally would be my 1, right? When I hit my first point after my 0 point, after my starting point, when I hit my next point, I usually go up to 1. Well, not anymore. I'm going to times it by a half, which is going to get me 0.5 this time. And then I'm going to add 3, which this time will get me 3.5. So now instead of hitting 1, this is going to hit 3.5, which I had to mark down on my y-axis. And I'm going to go through the exact same routine here. You can probably guess what's going to happen next, right? This is going to go down to 3, just like this one did. This, instead of being -1, it's going to be times by a half first, which will be -0.5, and then added to 3, which will give me positive 2.5. So it's going to hit down here at positive 2.5. And then it's going to jump back up to, again, 3, because this follows the same route as the other one. So my sine wave is going to look something like this. It's not going to be on the x-axis anymore because of these two values here. Now, if you remember from geometry, although why would anybody pay attention to that class, right? What we said in geometry, and probably in algebra 2 as well, is that this is basically just geometric transformations. This moves all the points up 3, which is why they're all moved up 3. This makes the peaks basically half as big. Now, it goes in the opposite order, essentially. This makes the peaks half as big first. So instead of being 1, it goes down to 0.5. And then the plus 3 moves them all up 3, which is why we end up at 3.5. You half the peak from 1 to a half, and then you bump it up 3 units. But again, that's going more geometric. I'm trying to stick with the algebra of the stuff here. So again, the way you tackle graphs is you have to know the base graph first. This is something you just have to have memorized. It's part of the unit circle. If you get a unit circle, great. If not, you just have to memorize it. Once you have this memorized in your head, then whatever happens to the theta, you do the opposite on your x's. Whatever happens outside the trig function, you do exactly to your y's. Opposite applies to the x, exacts apply to the y's. You follow PEMDAS. So you follow the multiplication division change first, and then you follow the addition subtraction change next. Same for x's as well, right? So that's why I divided by 2 to change my x's to get to counterbalance this, and then I multiplied by a half and added 3 to take account for the y changes. Now, what about cosine? So if we go to our unit circle here, how does cosine move? So cosine goes 1, oops, don't want to do that. 1, 0, -1, 0, and then back to 1. So let's write that down first. 1, 0, -1, 0, and then back to 1. So this is how a normal cosine of x would look in terms of a table format. But we don't have a normal cosine of x. We have all this other junk being done to it. So let's see what's going to happen now that we have these shifts involved, right? So what am I going to do to my x's? Well, right now I should say theta. Right now my theta is being divided by 3. Well, I'm going to do the opposite to counterbalance that. So I'm going to take all my thetas and multiply them by 3. So 0 times 3, so I'm going to just put a big times 3 here. So 0 times 3 is still 0. Pi over 2 times 3 is 3 pi over 2. Pi times 3 is just 3 pi. 3 pi over 2 times 3 is 9 pi over 2. And 2 pi is going to end up being 6 pi. So how's this going to look? Well, 0 is going to stay 0. Instead of being pi over 2, it's going to be 3 pi over 2. Instead of being pi, it's going to be 3 pi. Instead of being 3 pi over 2, it's going to be 9 pi over 2. And instead of being 2 pi, it's going to be 6 pi. So I get my x's done first. Again, the opposite of what's happening to your theta, that's what you do to your thetas. Again, this is theta, not x. I'm going to use them interchangeably. I apologize. Now, the y's, again, are nicer. They just go by how they look. So if I'm multiplying my trig by 4, that means I'm going to take all my numbers and I'm going to multiply them by 4 first. Again, PEMDAS order, right? Please excuse my dear Aunt Sally. Prince Albert in whatever the mnemonic for that one is. There's like 15 different mnemonics for PEMDAS. So that's a 4, 0, -4, 0, +4. Now, if we were just doing that, we'd be done. But I also have a +1 here. So everything needs to get bumped up by 1. So +1, +1, +1, +1, +1. This is going to end up at 5, 1, -3, 1, and then back to 5. So 5, 1, -3, 1, back to 5. So how's this going to look? Well, my first point is going to be 0, 5. So 0 all the way up here at 5. My first point. Then it's going to be 3 pi over 2 and 1. So 3 pi over 2 and 1. We'll put that 1 down here. Ah, gosh. My finger. Okay. So 3 pi over 2 and 1. Then it's going to be 3 pi and negative 3. So 3 pi and negative 3 is going to be somewhere down here. Then it's going to be 9 pi over 2 and 1 again. So it's going to bump back up to 1. And then it's going to be 6 pi and to 5, so like this. And so we get this little sort of parabola-ish looking thing that cosine graphs do, right? Normal cosine graph, remember, normal cosine graph is pi over 2, pi, 3 pi over 2, and 2 pi. And it starts at 1, it goes down to 0, hits negative 1, goes back up to 0, and hits positive, right? That's what these numbers here do. And so you can see it still has the same shape. It's just that the peak values are of different parts because we have stuff going on with the graph there, right? So cosine graphs always have this little parabola looking thing. Sine graphs always have this little, wave looking thing, right? They're both called wave graphs, but in terms of how they actually look, sine graphs will always have this shape, cosine graphs will always have this shape. The only thing you're changing is the numbers associated with the axes. And once again, x is changed by the opposite of what's happening to the theta. Y is changed by what's directly happening to the trig function, right? The outside numbers. I'm not sure why it's there. Yeah. So those are all the examples I kind of did because I don't necessarily want to overload if you're using this to help you study. Because this applies to, again, any type of problem you have. It follows this exact same routine. Look at what's happening to your x. Do the opposite to your key 5 numbers here, right? Again, these numbers never change to start with. You start with these, and then you shift based on what's happening inside the trig. And then once you have shifted all those, you can go ahead and plot them on your axis, and then you take care of your y values. You always start with this routine for cosine, or this routine for sine. 0, 1, 0, negative 1, 0 for sine. 1, 0, negative 1, 0, 1 for cosine. You always start with those, and then you shift. Again, multiplication shift first, or division, and then addition subtraction shift next. And then plot those, and then draw your curve, and you're done. Right? So if you have questions, comments, or concerns, again, let me know. I'll be glad to address any cases I didn't have. But that's, again, the general basics there. So I didn't necessarily want to cover every single nook and cranny because that'd be a really long video. But hopefully this will get you the basics, and you can sort of use that to apply to the other cases here. So should be a review, hopefully, rather than a full-on lesson. Thank you for watching. Have a good day. Good luck on this part of your final here, right?